Consider the mechanism for the reduction of a ketone to an alkane using the Wolff-Kishner conditions. So this reaction starts with our ketone, and then we need hydrazine. Loss of water will give us the hydrazone, which is just the imine with an amine attached to the nitrogen. So this process should really be considered to include acid, just a small amount, to get to that hydrazone, and then we'll switch over to base to finish the reduction. So let's consider the mechanism for the first part of the reaction, and that's getting to the hydrazone. So start with our carbonyl. We'll use the electrons on that to pick up a proton to get to the protonated version. And then the next step, we'll use the hydrazine electrons to add to the carbonyl. Electrons swing up. And then we'll have the hydroxyl group and the nitrogen, and then the amine still attached, plus charge on the nitrogen. So we can use a molecule of hydrazine to take off an extra proton, returning those electrons to the nitrogen. That will give us this intermediate, uncharged, with plenty of lone pairs. Next step. Protonation of the oxygen, which would result in protonated OH, which will end up being a pretty good leaving group. And now I can use the electrons on the nitrogen to swing in and release the water leaving group. Now we have plus charge on the nitrogen, and since water just left, we could use that to remove an extra proton, and that should give us our hydrazine. Next, we move the hydrazone product into base. We're going to switch out from slightly acidic conditions now to basic conditions. It's aqueous KOH, and we're going to heat this up. So what this can do for us is we'll use our hydroxide to remove an extra proton. Well, it's not really extra. It will create a negative charge on the nitrogen. That negative charge, we can push a lone pair in, push a lone pair down to this carbon. So we end up with our double bond and a negative charge on this carbon. And that gives us a pair of resonance structures. And so we have resonance stabilization at this point. We're going to continue on and use water now to our advantage and protonate that carbon. Now we have our imine. We'll use the next step in the process. Let's use the hydroxide to remove the proton, and that will leave us with a potentially very good leaving group. So let's draw the result of that.